All right, this is the back side of the worksheet we were working on in class last time, 6.2. To help you figure out what you need to know to be able to do the homework successful, we're going to look at the last 3 problems that were on the packet and talk through some tips and tricks on how to handle these types of problems. So this says to simplify the expression, and notice the expression is got a lot of different trig functions in it. It has a tan, it has a cosecant, it has a secant. If things are all very different and you don't see a specific way to get started, one tip is to try to write everything in terms of sine and cosine. So just to kind of remind ourselves, tangent, it can be written in terms of sine and cosine because tangent, this is one of our identities that we had. Tangent theta is the ratio of sine theta over cosine theta. So we're actually going to replace that top of that with that. So 6 minus sine theta over cosine theta. So that's now my new top. The bottom has a cosecant and a secant. Cosecant and secant are reciprocals. They're reciprocals of, remember, sine and cosine. Typically it's written as sine theta is 1 over cosecant, but if you have cosecant, you can also write that as 1 over sine theta. That's also true. And secant theta is 1 over cosine. It's just a reciprocal property written the other way. So on the bottom here, I have a 6 times a 1 over sine theta minus a 1 over cosine theta. Now the whole point of trying to write all of this in sine and cosine is to hopefully see a way to get this combined down to a singular fraction. Right now we have 4 little fractions essentially across the whole thing. So what I'm going to rewrite this as is this is 6 over 1 minus sine theta over cosine theta. And then on bottom, I can do 6 times 1, so that'll be 6 over sine theta minus 1 over cosine theta. In 136, this is covered in the section 1.4 at the beginning of the semester where you learn how to clear out complex fractions, essentially. One way of doing this is just to get a common denominator on both top and bottom. So we can use cosine theta as a common denominator for the top. So I'll multiply this by cosine theta over cosine theta to make this a common denominator with that. And on the bottom, they both are different, so we'll use each. So for sine theta needs cosine theta on top and bottom, and cosine theta needs sine theta. And whatever we do to the bottom, remember, we do it to the top of a fraction. So we're just trying to create a common denominator on top and a common denominator on bottom. So what I have now is 6 cosine theta minus sine theta all over cosine theta. So that's the top now as one big fraction. And then this is 6 cosine theta minus 1 times sine theta, so minus sine theta, all over sine theta cosine theta. Now, when you have one fraction stacked on top of another fraction, you're allowed to flip it and multiply by the reciprocal of the bottom. So my next line would be 6 cosine theta minus sine theta over cosine theta is going to be multiplied by the flip of the bottom, which would be sine theta cosine theta all over 6 cosine theta minus sine theta. When you have a binomial that's an exact match, like this is, you're able to cancel it out. So we can actually cross those out when we're multiplying. So that's just a common factor. We also have, since this is all times, right here, times, connecting it, these cosine theta, there's one on top and one on bottom. So we can also mark that match out. So this actually reduces down to just sine theta. So 6 minus tan theta over 6 cosecant theta minus secant theta. If you actually had a theta to plug in, say 30 degrees, and you worked out all of that information using the trig ratios of a triangle that matches a 30 degree, you would get the exact same answer as if you just plugged the 30 degrees into sine of theta. So this is what we call an identity. We'll teach you how to do these later. This was really just to explore manipulating a little bit using things that we know about sine, cosine, tangent, and the reciprocals. So that's all that was going on in this one. Example 5, there's 2 different ways you could approach this problem. I know they specifically ask you to use the fundamental identities to find the exact values of the trig functions. I still find that most students do better if they draw a picture here, because pictures are much more likely for students to be able to label things correctly than to just think in your head, is something positive or is it negative? So before we actually can answer anything about this one, we need to remind ourselves about something that I put into the video for the 6.2 notes. We learned that our 4 quadrants, if we have our angle in standard position, have some signs associated with them. In quadrant 1, x's and y's are both positive. In quadrant 2, x's are negative, but y's are positive. In quadrant 3, x's and y's are both negative. In quadrant 4, we get that this is positive for the x, but negative for the y. So notice you have all these different ordered pairs that have different sign combinations. Now, the reason this is important is because when we're in a unit circle, which is what we're going to be doing most of our work in, cosine ends up being just the x, and sine ends up being the y of the point. So you notice that cosine and sine are going to be directly related to the signs that are in those ordered pairs. So here's what ends up happening. All 6 trig functions are positive ratios in the first quadrant, okay? In the second quadrant, the sine theta will be positive, and its counterpart, which is cosecant. And the reason for that is because we have a positive y value, which is going to be related to sine. So sine and cosecant are positive in quadrant 2. In quadrant 3, because x and y are both negative, the only time you're going to get a positive is if it's tangent. It has to be a ratio of those 2 negatives. So tangent, and I'm going to put thetas on these, sorry. Tangent theta and cotangent theta are positive down in quadrant 3, and that's because they're a ratio of 2 negatives together, sine and cosine. And then in the fourth quadrant, you have that your y value is negative, so sine is going to be negative, but cosine, which is the x coordinate, is going to be positive. So this is going to be cosine theta and its reciprocal, which is secant. So what that means is in quadrant 1, all 6 trig ratios are positive ratios. They're positive fractions. In quadrant 2, only sine and cosecant are positive, so everything else would be negative ratios. In quadrant 3, tangent and cotangent are positive, everything else is negative. And then in quadrant 4, cosine and secant are positive, and all of the rest are negative. The way we remember this, so that you don't have to try to think through each part every time, is I have a little phrase. It's all science, circle the S, teachers, circle the T, are crazy. We don't actually write the word are, but just helps you remember that the last one's crazy. So all science teachers crazy. Go in order kind of counterclockwise. This says all of my trig functions are going to be positive. This says the sine family is positive, so sine S, but cosecant, remember, is also the reciprocal of sine. This says the tangent family is positive, so tangent and cotangent. And this says the cosine family is positive, cosine and secant. So I went through all of that because I want to draw an appropriate picture for what this is describing. This is telling me my cosecant is a positive number. They actually gave me the number, and I can put it over 1 if I want, because that'll help us for one of the next steps. So its cosecant of theta is positive, but cotangent of theta is negative because they're saying it's less than 0. So that already eliminates 2 quadrants right away. Quadrant 1, it can't be in quadrant 1 because nothing is negative in quadrant 1, so we know that's out. Quadrant 3 is also out for us because that is where cotangent is positive. That's the only other place that cotangent is positive besides quadrant 1. So we know that quadrant 1 and quadrant 3 are out just because of this statement right here, that cotangent theta is less than 0. So the question becomes, is it 2 or 4? Well, they told us a little bit because they said cosecant. Remember, cosecant is part of the sine family. So that means we are in quadrant 2. So this description, even though it doesn't seem like it's telling you anything, it's telling you exactly where to draw your triangle, because your sine family is positive and your cotangent family or tangent family is negative. So that is how we know where to draw this picture. So I felt like that was really important to talk about this again in case you didn't get that very clearly from the video. So I'm going to draw a picture and I'm going to label a triangle. I already know sine, so I can go ahead and come down here. Sine of theta is just the reciprocal of the 7 over 1. So that would be 1 over 7. Cosecant of theta is, remember, 7 over 1, which is just 7. So let's draw a picture for that. So we're in quad 2. And we're not drawing accurate lengths, but we have a theta. Your theta is always centered at the origin point. And remember, sine is 1 over 7. Sine is opposite, so that would be this, over hype. You do want to make sure that this is listed as the correct signs. A y over here is positive, radius is always positive, and anything we find here, even though I don't know yet the answer, it's going to be negative because on this side, the x-axis is negative, and this is the x length. So I already know that this is going to be a negative answer. And then we need to use our Pythagorean theorem. So a squared, we don't know, plus b squared equals c squared. So this would be x squared plus 1 equals 49. And x squared, take that over, that would be 48. And then we're going to take the square root of that. And this would be a negative, and I know that because of the quad 2. That's why I'm choosing a negative, because when you take a square root, you're really supposed to take a plus or minus. We don't write that in, and we don't write any sign in if it's looking for the hypotenuse, because that is supposed to be positive. But if you're trying to find the x or the y, you need to make sure you know if you're in the right quadrant and what that sign's going to be. So normally we would write plus or minus when we take a square root, but because of the quadrant we're in, we're choosing the negative. And then this is 48, and then we can break that up because 48 is 16 times 3, so that's negative 4 on the square root of 3. So that is this side right here of my triangle. Once you have your 3 sides of your triangle, most people are fine at this point to make the rest of the ratios. So we need cosine of theta and tangent of theta. We need secant of theta and cotangent of theta. Okay, so cosine would be, remember, adjacent over hype. So that's negative 4 square root of 3 over 7. Tangent is sine over cosine, or remember, y over x. So it's easier to do y over x because then we don't have to worry about the 7s because they're going to cancel out anyway. So it's 1 over negative 4, or negative 1, 4 square root of 3 is the bottom. We would rationalize that by multiplying top and bottom by a square root of 3. So it looks like my tangent is going to be negative square root of 3 over, that's going to be square root of 9, so that's 3. 4 times 3 is 12. So it's kind of a funny answer. So that's my tangent. There's my cosine. There's my sine. Let's get our reciprocals. We already knew cosecant was 7. If we flip this one, we will have to rationalize. That's going to be 7, so negative 7 over 4 square root of 3. And I'm going to give myself some more room by erasing my cotangent one. I'll write that back in a minute. So I need to multiply top and bottom by square root of 3. So that's negative 7 square root of 3 over square root of 3 times square root of 3 would be 9, square root of 9, so that would be 3 times 4 is 12 again. So both of those ended up with a 12 in their denominator. And then cotangent is a little bit easier if you flip it before you actually rationalize. Remember, tangent was originally this. If you just flip that, you don't have to rationalize anything. So that's negative 4 square root of 3. If you flip the answer you have here at the end, you're going to have to rationalize, and then it reduces back down to negative 4 square root of 3. So notice 4 of the different trig functions were negative, and the only ones that were positive were the sine and cosecant because that's the quadrant that we're in. The quadrant is 2, where that's the only possibility for positive ratios. Okay, so that's the end of that one. And then the last one was number 6. We're looking at a word problem and application problem. So we're going to try to draw a picture. It says a rocket is fired at sea level. So sea level is supposed to be considered flat. And So it's being fired up at an 83-degree angle. I'm not drawing that for perfection, obviously. So here's my rocket. Yeah, not good at drawing. So there's my rocket. And it's going to travel through a distance of 10,500. So that means that's actually the distance that this slanted line is, because it's traveling that distance. And we want to find its nearest altitude foot, and we want to find its altitude and nearest feet. So that means we're looking for this height right here. So I kind of drew too far out, but it's fine. We're just looking for, after it's traveled this far, how high up in the sky would it be? So what we want to do first is we want to realize that the reference angle is 83. So this is where we're referencing from. And since this is an altitude, that's a perpendicular measurement of height. So we just need to reference this from the triangle. This would be the opposite to that angle, and this would be the height. The trig ratio that uses opposite and height is sine. So this would be sine of 83 degrees equals opposite, which is h, over the height, which is 10,500. We'd want to solve for h, so we would multiply 10,500 to the other side. And then we're going to need our calculator to get this approximation. So I'm going to pull mine up. And let's do sine of 83. I'm in degrees. You need to double check that first. So that's sine of 83 degrees, which is 0.99 something. And then without clearing it, because you don't want to round too early, you're going to times that by 10,500. Oops, too many zeros. And then that will give us an approximation. Now, nearest foot means whole number. So this would be 10, 4, 2, and then the 1's going to get bumped up to a 2 by the 7. So the height is approximately 10,422 feet in the air. And that's it for this video.